This short video may be useful in helping you finally put everything together. So this is the stylized way of doing things. So what you want to do is start with the grams of the starting stuff over 1, because that's going to serve as your given in the calculation. Next, you want to do 1 mole of the starting stuff on top with its molar mass on the bottom. Next, we do whatever number of moles. Let's get this buttoned up. Yeah. There we go. Yeah. All right. So, some y number of moles of the ending stuff and z number of moles of the ending stuff. So I just added in the ending stuff there, so that would be part of this. And now we have the molar mass of the ending stuff over the moles of the ending stuff. Notice molar mass is on top here for the ending stuff, but it's on the bottom here for the starting stuff. Because we're going from grams to moles, and then we're going from moles to moles, moles of the starting stuff to moles of the ending stuff. And I just realized that this is where I need to have this as starting stuff also. Okay, this is where we actually do the changeover, this fraction right here. So why don't we make that in a different color? Now that we have the moles of the starting stuff changed to moles of the ending stuff, where did this actually happen? Well, guess what that is? And now once we have the moles of the ending stuff, we can change those moles of ending stuff into grams using the molar mass on top and the moles of the ending stuff on the bottom for our last fraction. And that gives us the theoretical yield. Now we're going to apply it to one of our homework problems. So where in our homework problem on the right side is the actual starting stuff? Okay, that was the hydrofluoric acid. And that becomes our starting stuff grams over 1. Then over here, now looking on the right again, this is our actual stuff. This is the stuff that was told that we get this from the experiment. Okay, so that's going to come in next. But first of all, we have to go back over here on the left-hand screen and take our molar mass of the starting stuff, which over here is this. Okay, this stuff was given to us. We put that in over here. Here we're doing the molar mass of that. Now next we have to go to a balanced equation to do our next step. Okay, that's where this is going to come in. And the balanced equation for this reaction, which is right here. So now we're trying to change moles of the starting stuff, which in this case is the HF. So starting stuff is Y. And the HF is sitting right here with a coefficient of 6. So Y would become 6 moles of the starting stuff. Oh, ending stuff. I'm sorry. The starting stuff is down here. So moles of the starting stuff is 6. And moles of the ending stuff is up here, and the ending stuff is this guy, the SiF6, so the coefficient of that is 1, and that would be the Y. So we have 1 for Y, and down here we have 6 for the Z. And now the next thing that we need to do is get the molar mass of this guy, and we're going to put that right here. And now I have 1 mole of that ending stuff, which is the H2 SiF6, okay? And whatever molar mass I calculate is going to be up here. When I run the numbers on this, I'm going to get the theoretical yield. And then, of course, you know that the theoretical yield will be on the bottom of the percent yield calculation. And so let's hold on just a minute. So we have whatever is the theoretical yield that we just calculated on the bottom of the fraction, and the amount that is given right here on the top of our fraction, and that will be our percent yield calculation. And that's going to be how you use this screen here on the left as a model to get to your theoretical. And once you have your theoretical, you can use that to go ahead and calculate the percent yield. And that's how you do these problems. Go.